Hello, hello, hello. Great. You're welcome to God Academy, and we begin our exams prep tutorials. So, if this is the first time you are visiting God Academy, kindly subscribe and please share to your friends as well, those whom you think is going to benefit. Okay. So the first problem says find the rank and nullity of A, which is a vector, right? Which is having 4 columns and 3 rows. So let's go straight solving this problem. So how do we find the rank and nullity of a vector? To solve this problem, first of all, when we talk about rank and nullity, so we are talking about um, rows of linearly independent rows in any vector. Okay, so for this one, you are going to apply the row echelon to break this down. Then after that, after reducing it, so the process is called reducing, right? After reducing, you will then identify the set of linearly independent rows, which are rows which are not all zeros. Okay, so observe closely as I take you through the problem. So I have my matrix A given as 1, 2, 0, negative 1, 2, 6, negative 3, negative 1, 3, 10, negative 6, negative 5. So you can try this problem as well on your own. You can pause and try and see if you get it. Time yourself because you have the paper tomorrow. So you should make sure that you set exams parameters. So how do you reduce this vector to the row echelon form? Always remember that we need what we call the leading one. Okay, we always need the leading one. So this one we are not going to touch it because of that. Since the first element of our first row is the leading one, we don't bother ourselves to reduce anything. So we are not going to actually touch this first row. Okay, that is what you're going to do. So from there, we look at the second and the third rows. Those are our points of interest. So we need to eliminate these two, eliminate these three as well for our reduction. So the first step, let's do our first reduction. So as I said, the first row is not going to be touched because our first element is 1. If our first element wasn't 1, that is when we would have touched the first row. Once your first element is 1, there is nothing you can do to this row. So you write your 1, 2, 0, negative 1. Now, how do we eliminate these two? This is 2, right? How do I get rid of these two? Now, with my row operations, you can clearly see that if I multiply my first row by 2, I will get this one becoming 2. Then I can subtract it from this row. Then this will be 0. So it's mostly a manipulative process, okay? It's not fixed. And be interested in only the first numbers. Forget about the rest. So I have 1 and I have 2. How do I get rid of the 2? I simply multiply my 1 by 2 and subtract. So I will just say that my row 2 minus 2 times row 1. As simple as that. That gives me what? 2 minus 2 will be 0. 2 times 2 is 4. 6 minus 4 will be 2. That not it? Then 2 times 0 is 0, right? Negative 3 minus 0 is still negative 3. Now, 2 times negative 1 is negative 2. Negative 1 minus 2 becomes what? Negative 1 plus 2. Is that not it? Let's do it well. So I have negative 1 here. I'll multiply it by 2, and that will give me negative 2. I'm subtracting whatever I get here from whatever I have down here. So this becomes negative 1 minus 2. Okay, so that is positive 1. All right. Then my third row, remember here is 3. For me to eliminate 3, then it means I can still multiply my first row by 3, then subtract it from my last row. So I'll have row 3 minus 2r1, as simple as that. That gives me 0 again. Then 3 times 2 is 6. When I subtract it from 10, I get 4. 3 times 0 is 0. When I subtract, I'll still get negative 6. Then finally, 3 times negative 3 is negative 3. When I subtract, it's going to be plus, right? I'll end up getting negative 2. As simple as that. So this is our first step. So you've realized that we've reduced the first 2 to 0. Now we are only left with one more thing. So as our in an attempt to reduce this to an aper triangular matrix, remember that what we are trying to do is we want to reduce this whole system to an aper triangular matrix so that when we multiply it by our unknowns, we can easily find the corresponding unknowns. So with our aper triangular matrix process, meaning that we still have to go forward, breaking it down. Let's come down and see how we can go forward with this. So I'll have this, which is 1, 2, 0, negative 1, 0, 2, negative 3, 1, right? Then I also have, so now at this point, let me hold on with the second one. You can clearly see that I can get rid of this 4, right? By just multiplying 2 by these 2. So therefore, my row operation becomes what? Row 3 minus 2 times row 2. As simple as that. So that becomes 0. When I subtract, I get what? 0, right? Then 2 times negative 3 is what? Negative 6. When I subtract, it becomes negative 6 plus negative 6, positive 6, right? That gives me 0 as well. Then finally, 2 times 1 is 2, right? When I subtract, what do I get? 2 times 1 is what? Is 2, right? When I subtract, I'm going to get negative 2 minus 2. That means negative 2 plus 2, right? And I have 0. Therefore, this is where I've reached. At this point, there is nothing I can do again. So I can clearly deduce my rank. So the only thing we are interested in is what? Rank. And what is rank? Rank is a set or the number of linearly independent rows we have in our system here. And that is this and this. That's all. These are the sets of linearly independent. This one is not linearly independent. It's linearly dependent. So it is out. So therefore, our rank is simply equal to 2. Now, for the nullity, please don't worry. Nullity, we don't calculate for nullity. Once you get your rank right, you should expect to get nullity right. The total number of columns here is 4. So the rule says that whenever you add your rank and your nullity, it should be equal to the total number of columns, n. So number of columns. Therefore, I'll have my rank 2, my nullity, which I don't know, is equal to 4 because I have 4 columns, 1, 2, 3, 4. Therefore, my nullity is equal to 2. As simple as that. My nullity is equal to 2 and my rank is 2. And that solves the problem, which is our first problem. Find the rank and nullity of the system given. So, if this is your first time visiting this channel, please kindly do well to subscribe and don't forget to share to friends with me. It's gonna be helpful too, right? Okay, so let's go to our second problem. Which problem? Good. Have an interesting problem here. How we can solve that. So let me expand my. I hope now it's clear. So it says that find key such that the following system here is consistent. The following system here is what's consistent. So this introduces a very brilliant word called consistent. Then we have what we call an inconsistent system, right? So when you talk about consistent and an inconsistent system, I can take a very short time to explain briefly. So we are trying to say that we want to find an equality between the rank of a matrix A and its augmented matrix A slash B. So if the rank of a matrix A and its augmented matrix is the same, we say the system is consistent. But if the rank of a matrix A and its augmented matrix is not the same, we say it is inconsistent. You should understand these basic terminologies in algebra before you sit for a paper. Let's solve this problem straight away. And we have, let's take the coefficient, right? As usual, we find what we call the augmented matrix. So we have 1, -2, -1. Then you introduce the augmented parts. I'll have 1. I'll have my second row, -1, -3, 1. I'll have -1. I'll have -5, -8, 5. Then I have k. As simple as that. So you realize that this part is our matrix A and this part, the entire thing becomes our augmented matrix. So if the rank of this side is the same as the rank of this side, we say the system is consistent. But from the question, we've been restricted that surely our system should be what? Consistent. So for our system to be consistent, then it means that we should make sure that the rank here is the same as the rank here. And that will help us find the value of k. So let's solve it. We use a row echelon form to reduce this into an aper triangular matrix as we always do. Now, since our first row is having a leading 1, we are not going to touch it. We won't do anything to it. So please take note. These are some basic things. Once you have your first row as 1, so 1, maintain -2 is -1, then I have my 1, which is here. As simple as that. Then when I come to my When I come to my second row, I can clearly get rid of this -1 by adding row 1 to row 2. So my operation is row 2, which is equal to row 1 plus row 2. As simple as that. Therefore, I'll get here to be 0. Clearly, this place when I add, I'll get -5. Is that not it? As simple as that. Then also, what do I get again? When I add these two, I get 0, right? Nicely. Then when I add these two, I also get 0 beautifully. At this point, we are still not done. We still have to find a way to get rid of this -5 here. So we can easily multiply this. Either we multiply the first row by 5, then add, or we multiply here by 5 and subtract. Any of them should work. So we can use our first row as our pivot. Okay. So let's multiply our pivot by 5. We are going to have 5 by 1. When I add it to 5, it becomes 0. 5 by -2 is -10. When I add this, I'm going to get -18. 5 by -1, I'm getting -5. When I add it to this, I'm getting 0. Right. 5 by 1 is what? 5, right? When I add it, I'm getting k plus 5. As simple as that. Is there more I can do at this point? Let's see. So you can clearly see that at this point, I can break my system down and I'll have, let's see, I wrote that right. Okay. So I think that there is a problem with my question, which I need to update. Yes. Um. Okay. Let's see. So at this point, what you're supposed to do is for us to swap, right? Is for us to swap. But before then, I was using this. I multiplied I think 5 by my first row, and I added it to this, right? So let me see. Okay, you let's move on solving with the values you have. So with these values that we have right now, we have -5. You can divide through by -5, and that side we are going to have 1, -2, -1. You have 1, right? Then this whole row, I will get 0, 1, 0, 0. Then the last row, I'm going to get 0, -18, 0, a plus 5, right? Good. So at this point, the reason why our question has got a problem is that we are supposed to get an all zeros here for us to actually find the values of k for it to be consistent, right? Because for at this point, for us to say that for the value that will make this system consistent here, we need to get a particular rule which will affect our vector and as well as the augmented matrix. So um I would have to update this problem, but let's move on to the next problem before we continue. Okay, so let's move on to the problem. I'll attend back to this problem shortly. So, good. Let's do some eigenvalues and see how these problems algebra. Okay, so it says that find the eigenvalues and their corresponding eigenvectors of this matrix 3 by 3 with entries 3, -2, -2, -2, 3, then 2, right? Then you also have 3, -3, -2. So let's solve this problem. So as usual, for you to start any eigenvalues or eigenvectors problem, you start with what you call the characteristic equation. So you open your matrix A, then you find 3 minus lambda, -2, -2, I'll have -2, 3 minus lambda, 2, right? I'll have 3, -3, -2 minus lambda, right? So at this point, I'll find the determinant of this 3 by 3 matrix. So to find the determinant, just take you want to find our characteristic equation. So you just have to find the determinant. So let's simplify this expression carefully. Sometimes it's not about the difficulty of the problem, but it's about how careful you can be. So if you are very careful with algebra, you wouldn't make some errors which are preventable. So let's see. You start with 3 minus lambda, right? Open brackets. It will cancel this side and this side, right? So I'll get these two by two matrix. So that will give me, let me use different color code. I'll have negative 3 minus lambda in one bracket, multiplying negative 2 minus lambda, right, in another bracket, then minus negative 3 times 2, right? That will become positive 6, or in the bracket of what? 3 minus lambda, like this. So it is plus minus plus. Then I go to the second one, minus 2. Open brackets. I also open again. At this point, I'll have, at the minus 2, I'll have this row and this going away. So I'll be left with this, and this, right? So 2 times, negative 2 times this. Negative 2 times negative 2 minus lambda, right? Minus 3 times 2. That is what? 6 plus. Then finally plus negative 2 here, open brackets. You're going to have the whole of this row and the whole of this row going away. I'll be left with these 2 by 2. So negative 2 times negative 3, as simple as that. Minus the expression 3 multiplying negative 3 minus lambda, like this. So at this point, we have deduced our equation and we are supposed to solve. So the rule is that the determinant of our matrix is equal to 0. As simple as that. So let's solve this. This is maintained 3 minus lambda. I won't touch it. Let's wait. Then I'll simplify what is inside here. So negative 3 times negative 2 is what? 6. Negative 3 times negative lambda is what? Plus 3 lambda. Negative 3, negative lambda here times negative 2 is positive 2 lambda. Then negative lambda times this is what? Positive lambda squared, like this. Plus 6. So let me clean this. So this whole thing plus 6, right? All into the bracket. Then minus 2, bigger bracket open here becomes negative 2 this, I'll get positive 4. Negative 2 times this plus 2 lambda, right? Then minus 6 outside. Then I'll have this minus 2 out. This becomes positive 6 minus the expression here, which is what? Negative 9. No, so this is minus minus. So let me maintain my minus outside. I'll have my negative 9 inside. Then I'll have minus 3 lambda, right? So just open your eyes and do the computation very carefully. This should be equal to 0. At this point, still keep this open. 3, this, right? I'll have 6 plus 5 lambda. Remember, there's under 6. Let me make it 12 straight away. We can do that. Or more like that. We have 12 plus 5 lambda plus lambda squared minus 2 open brackets. This is 4 minus 6 is negative 2. So 2 lambda minus 2. And finally minus 2 open brackets. 6 minus. So here it becomes, or the minus is, so 6 plus 9 plus 3 lambda, right, is equal to 0. So I'll have 3 minus lambda. I'll have, this is what? 12 plus 5 lambda plus lambda squared minus, here I'm going to get 4 lambda plus 4. At this point too, everything opens up, right? I'm simply going to have 6 plus this will be 15. Let me do that simple. So 6 plus 9 is what? 15. Let me write that. I'll have 15 inside here, right? So I'm done with this. This multiplies to negative 30 minus 2, that is minus 6 lambda is equal to 0. At this point, I need to split this, right? So 30 times this, I get 36. 30 times this, I get plus 15 lambda. 30 plus 3 lambda squared minus 12 lambda. So let me make my square word, lest I make a mistake. Then minus lambda times this, minus 5 lambda squared. Then minus lambda cube. Then I continue from this. So at this point, see, minus 4 lambda minus 6 lambda is minus 10 lambda. I have 4 minus 30, which is negative 26 equal to 0. You are still simplifying. Just open your eyes. I have my minus cube. It will stand out, right? Followed by my squared. I have 3 squared, 3 pi lambda squared minus 5. So that is minus 2 lambda squared. Am I on the right part? So minus 2 lambda squared. Then I'll have 15. I have 15 lambda here, right? So 15 lambda, then minus 10 lambda, right? I'll have, let me keep all the lambda. So plus 15 lambda minus 12 lambda. Then I'll also have minus 10 lambda, right? Then I'll have 36 minus 26 equal to 0. So what do I get? I have negative lambda cube minus 2 lambda squared. Okay. Then this is 15 lambda minus this minus this. So 15 minus 22 is minus 7 lambda. Then I'll have 36 minus 26 as plus 10 is equal to 0. Interesting. So this is the same as minus lambda cube plus 2 lambda squared plus 7 lambda minus 10 is equal to 0. So actually the risks for eigenvalues and eigenvectors is you making any unwanted error in the course of computation. So because of that, you do constant screening as you move ahead, right? So we had this multiplying this expression here. Okay, let's do it here, right? So we did this inner. We got a 6 plus 3 pi. That was this times this plus 6. So 3 times this is 6 plus 3 lambda. Then we had the plus 2 lambda. We got the plus lambda squared here, right? Nicely. Add our plus 6 here. Everything inside, going to multiply this, right? Minus 2 came here. We had this times this, we have 4. This, we had positive 2 lambda. Then we also have our minus 6, all within the brackets. We came to the last one, minus 2. Here became positive 6. Minus sign is out. We had minus 9. Then we had minus 3 lambda inside is equal to 0. This still came. We had 6 and 6 giving us 12. This and this giving us 5. This maintain minus 2. 4 minus 6 is minus 2. We had this nicely. Then minus 2 once again. I have 6 minus minus 9, which is 15. 6 minus this, which is what? Um, so I got 6 minus, that's 15 here, right? So we have, this is plus lambda, 3 lambda, positive. So this will multiply this expression, and this expanded to negative 4 lambda plus 4, right? This is minus 30 minus 6 lambda. Nicely done. So at this point, you multiply this here, and we got this times this, which is 36, right? 3 times this is 15 lambda. This is 3 lambda squared, right? Became negative lambda, negative 12 lambda. That is here. Then this is negative 5 lambda squared, then negative lambda cube, minus 10 lambda, right? Then you have minus 26. This and this gave us minus 10, then minus 20. Then we came down here to get lambda cube, that is this, minus, so 3 minus 5 is minus 2 lambda squared, have plus 15 lambda. Then I have minus 12 lambda minus 10 lambda. That gave us minus 20. That is going to give us 15 minus 22 is 7. And finally, we have our 36 here and minus 20 for 0. So let's enter this into the calculator and see what you get, whether you get positive. So 5, 10. So 1, 7, 4. So we are getting lambda 1 to be equal to negative 1 plus root 7. Lambda 2 to be equal to negative 1 minus 7. Okay, these are unexpected um, roots, I'll say. So let's try and find the eigenvectors using this root to see the feasibility and the complexity, right? So I didn't expect this. Good. So with this, we go back to the problem, right? So in mathematics, you don't have to fear the process. Make sure that whatever you are doing is right. It's not about the scary values you are getting. No. So far as your process is right, and after going through, you think that everything is all right, then there is no problem with what you are doing, right? So let's reproduce this work here by writing it. So how do I get, let me write mine. So I can copy my question down. Good. So at this point, I can find my first eigenvector. To find my first eigenvector, I'll have 3 minus, my first one is what? Minus 1 plus root 11, right? Negative 2, negative 2. I'll have negative 2, 3 minus negative 1 plus root 11. And I'll have 2. And I'll have 3 minus 3, negative 2 minus negative 1 plus root 11. To simplify this, I'll have, this is 3 plus 1 is what? 4 plus 11. Negative 2, negative, negative 2 here. Then I'll have what? This becomes what? 4 plus 11. 2. I have 3, negative 3. This becomes what? Negative 2 plus 1 is negative 1 plus root 7. This multiply our sets of x1, x2, x3 is expected to give us 0, 0, 0. So is it possible to use row echelon form to do wonders here without complexity? So at this point, what can we do? So we can beautifully shift this row up, right? We want to get a leading one. The idea behind row echelon simplification is to get a leading one. So as I said, never be scared about the values you are getting, but make sure you are doing the right thing. So shifting row 2 to row 1, I'll have negative 2 here, 4 plus root 11. Then I'll have 2. Then I'll have, this side is going to be negative, no, I'll bring my 4 plus root 11 here, negative 2, negative 2. I'll have my 3, negative 3, negative 1 plus root 11 down here. So let's break this down, okay? That should be the focus. So in breaking it down, let's me use this side. How do we get our leading one? By dividing through by negative 2. I'll get here to be 1. Negative 2, when I divide this through by negative, what am I getting? I'm getting negative plus root 7 over 2, right? Then negative 2 here, I'll get negative. This side, I can equally do same, okay? So I'll have my 4. So I'll have 2 plus root 11 over 2. right? Then this will be negative 1, negative. This becomes dividing through by negative 3. I'll get 1, negative 1, then negative 1 out of 3 plus root 11 over 3. So at this point, where are we heading towards and what are you doing? So mostly when you get any root which has square roots, what is the difference is the plus and the minus, right? So mostly the difference between your answer shouldn't be so wide. Just using one should be enough. So at this point, let's see, is there any way we can save ourselves? Yes, by switching this up, right? So I'm going to have 1 minus 2 plus 11 over 2 minus 11. When I switch my third row up, I'll have 1, negative 1. I'll have negative 1 over 3 plus root 11 over 3. Then this will come down, right? Okay. I think there is no need for me to swap. I can straight away just subtract it, right? So when I subtract my first row from my third row, I'm going to get 0, right? So I'll get 0. Then I think swapping wouldn't also be bad, right? So I'll have 0. Then this side will give me when I subtract this, this will be positive, right? I'll get 1 plus root 11 out of 2. When I subtract this from um this whole expression, negative 1 plus 1, I'm going to get 1 out of 3 plus 1, right? I'm going to have the expression negative 3, which is what? Plus 2 over 3, right? Plus 2 over 3 plus root 3 over 3. Then we push our 2 plus root 11 over 2 minus 1 down. At this point, is there any hope to get rid of anything? That's going to be extremely difficult, right? Extremely difficult. So let's hold on with this. But before then, I think we can multiply through the first one by this, right? We can multiply through the first one by this and subtract by itself. So if I multiply through by 2 plus root 11 out of 2, what am I getting? Sorry for this long process whilst we have more questions to be solved. So sorry about that. We have 2 plus root 11 out of 2 here. I'll multiply through by the first one. I'll have 2. No, I won't do this inside. So this time this, obviously note that this will be 0, right? Yeah. So I'm just multiplying through this by this so that I can subtract and get that to be 0. So I'll have my 1 still maintain plus root 11 out of 2 still maintain minus 1 maintain 0. 1 plus root 11 out of 2. I'll have my positive 2 over 3 plus root 3 over 3. I should have combined them. So at this point here becomes 0, right? Then here becomes negative 1 minus. Remember this one, I'm multiplying this times this. And it's something like 2 plus root 11 out of 2 times negative 2 plus root 11 out of what? Right? So this gives us, you can punch this one into your calculator for ease of calculation, right? So that will give us open brackets 2 plus. I just want you to appreciate the fact that we are getting a square root, but yet we are still pursuing to solve it. It's not an error to get, but mostly in the exams, you are not supposed to complicate. So the questions are such a way that you are going to get some good integers for you to work around, but not always the case. Sometimes you can get some rough values. But please, if you get square roots, do well to check your answer. So the answer is negative 5 over 4. So I'm getting negative 5 over 4 at this level. Then here too, I'll have the same thing multiplied, which is going to be negative. I'm going to have negative 2. When I multiply that, I'll have negative 2, right? I'm multiplying negative 1 by this, minus 11 over 2. So minus 2 minus root 11 over 2, as simple as that, right? Minus 2 over root 11 over 2. When I get that, I'll come and subtract from this as well, right? You multiply this and subtract from this. as you have been doing. So I'll come and subtract this. I've got negative 1 minus, it's going to be negative 1 plus 2 plus root 1 plus 7. We are still not done. We have reached somewhere very good, and that is so beautiful. So, is there anything to be done at this point, which we can use to eliminate any of the zeros here? So, I have this and I have this. How do I eliminate my negative 5 over 4 or any of this? That is going to be a hell, right? So, if you want to do some simple elimination, so sometimes one way you can use to get around this is doing this. So intentionally say that what value, okay, let's say negative 5 over 4 times what value would give me 1 plus root 11 on 2. That will help us get a multiplier by this, and we can subtract from this and make it 0 and push it down. As simple as that. Okay. So for us to get that, what do? We find x. X is equal to 4, negative 4 over 5 times the expression 1 plus root 11 over 2. Nicely, right? So this gives us negative 4 over 5. Then the 2 here goes into this, 1 goes there. So we get minus 2 over 5 root 11, right? So interesting, we are going to get negative 4 minus 2 root 11 over 5. So let me clean here. So I need to multiply this here by this expression. So I need to multiply my last row by this expression. Okay. So I'll have my last row by that expression, and it will give me, so I'm multiplying my last row by this expression. So I'm supposed to get a value that will cancel this. So here we can use our calculator nicely. That we know that when I multiply this by this, I can erase this. So finally, I'm supposed to get 1 minus 2 plus root 11 out of 2, 1, 0. Then here I'll shift it down and make it what? Negative 5 over 4. Then this becomes 1 plus root 11 over 2. Then this row becomes 0, 0. But you have to find a value that will be here nicely. Okay. And that will be, oops. So that will be quickly, I will have to just simply multiply um so this one, right? I'll simply multiply this by this expression and subtract from this. That's going to be very long. So let me quickly move to the next problem, but I think that you saw what you're doing here and you appreciate it so well. Okay, let's take some interesting problems here. So find the point at which the line with parametric equation x is equal to 2 plus 3t, y is equal to negative 4t, then z is equal to 5 plus t intersects the plane 4x plus 5y minus 2z is equal to 18. So this is a problem. So we should find a point at which the line with parametric equation s is equal to 2 plus 3t, y is equal to negative 4t, and z is equal to 5 plus t intersect the plane 4x plus 5y minus 2z equals 18. We need a point. That's what we need, right? So what do we do to solve this problem? Let's write our parametric equation again. 2 plus 3t, y is equal to negative 4t, then z is equal to 5 plus t. So we have here. So please, whenever they tell you to find a point of intersection, you are trying to merge the two. So what do we do? Wherever you see x, you replace it with the parametric equation. Wherever you see y, replace it with the parametric equation. Wherever you see z, you replace it with the parametric equation is equal to 18. What is this? 8 plus 12t minus 20t minus 10 minus 2t is equal to 18. Right. So I'll have minus 10. This I'll have negative 2. Minus this I'll get negative 8t. Then I'll have minus 2t equal to 18. Right. So I have this go back. I have negative 20t is equal to what? 20. Right. A negative 10t is equal to 20. Therefore, t is equal to negative 2. Now that you found t to be equal to negative 2, the question says you should find the point at which they are meeting. What do? You put this negative 2 into the respective parametric equation to find the component of the point. So s will simply be equal to 2 plus 3 multiplying negative 2. Y will simply be equal to negative 4 multiplying negative 2. Z is simply going to be equal to 5 minus 2. So my s becomes 2 minus 6, which is negative 4. Y becomes 8. Then z becomes 3. Therefore, my point is negative 4, 8, 3. As simple as that. As simple as. Let's take another problem. So we are going to. So this is a problem. It says that find the point. No. Find the distance between the parallel planes. We have 10x plus 2y minus 2z is equal to 5, and 5x plus y minus z equal to 1. So I'm to find the distance between these two parallel planes. Okay, so solution. To find the distance between two parallel planes, we need a point on one plane, then we need to put it into the other plane. So there is a standard formula, please. Let me write the standard formula for you. For you to find the distance between any two planes, the formula is d is equal to absolute of ax1 plus by1 plus cz1 plus d all over the square root of a squared plus b squared plus c. As simple as that. So our x1 and our x1, y1, z1 is simply a point on one plane. Then a, b, c is also the direction of one vector. As simple as that. So let's calculate. So here, the first thing we are supposed to do is let's find one point. So using the first plane, which is 10x plus 2y minus 2 is equal to 5, we should find one point. To find a point in a plane, set two variables to 0. So let y equal 0, z is equal to 0. What do I get? I'm simply going to have 10x is equal to 5, s is equal to half. Therefore, wherever I see x1, I'll put half, y1, I'll put 0, z1, I put 0. So absolute of a, my a is simply my 5. Okay, this is my reference, the direction plane that I'm using. So I'll have my a, which is 5, multiplying half, plus b, which is 1, the coefficient of y, multiplying 0, minus c, which is what, negative 1, so becomes what, plus 1, multiplying 0, right? Okay, it's plus and it's negative, so it's minus. Minus 1 multiplying 0, then plus what, my d, which is minus 1, or absolute over what, square root of 5 squared plus 1 squared plus negative 1 squared. So at this point, what am I getting? I have absolute of 5 out of 2, right? So everything here will be 0. I have 5 out of 2 minus 1. So it is 2.45 minus 1, which is what? 1 point what? 4, right? So you enter this everything into your calculator. You are supposed to get square roots of 3 over 6, right? So the answer is square root of 3. Okay, let's check this question. It says that is W, which is equal to 1 comma negative 4, a linear combination of V1 is equal to 2 comma 10 and V2, which is equal to negative 3 negative. Okay, good. My V2, which is negative 3 negative 15. So to show that this is a linear combination of this, we introduce some variables called C1 and C2. Okay, so my W is what? 1 negative 4, and it's equal to linear combination of this. So I'll say that C1 times V1 plus C1 times V1 plus C2 times V2. So if I'm able to get correctly right solution for this, then it means that it's indeed a linear combination. So 1 negative 4 is equal to, I'll have what? 2C1 10 C1 plus negative 3C2 negative 15C2. Therefore, I'll have two systems. 2C1 minus 3C2 is equal to 1. Negative 4. So I have 10 C1 minus 15 C2 is equal to negative 4. I'll solve this simultaneously. So to solve this simultaneously, I'll enter this into the calculator. I'll have 2, negative 3, 1, 10, negative 15, negative 4. So the answer is giving me error, right? You get mass error because these two here, let's see something. If I'm to break this down, what am I getting? 5 goes into 10, I'll get 2C1. 5 goes into 50, I'm going to get what? Negative 3C what? 2. Then when I divided through by 5, right? I have 0.8. Therefore, seeing that this year and this year are the same but with different days, then this our equation is not consistent. Okay, so this is not a linear combination. If we had gotten proper values, let's say C1 is this, say that indeed it's a linear combination of the other. Let's solve one interesting problem inside here. I think this should be the problem. Interesting. So it says that show that our system here, it's getting late, so let's use this as our last problem. Then yeah, show that our system here is inconsistent. Just show that it's inconsistent. That's the problem. Solution. How do we show that this system is inconsistent? So I'll first write my augmented matrix. That's the first step. I'm going to do some nice editing here. So 1, negative 2, negative 3, 1. I'll have negative 4. Second row, negative 3, 7, negative 1, 1, negative 3. I'll have third row 2, 5, negative 5, 4, negative 3, 7. I have negative 3, 6, 9, negative 6, negative 1, like this. So once I have this down, the next thing is to apply my row operations, as simple as that, row operation. So clearly I can divide through by negative 3 down here. It's so obvious, right? My first one is maintained because I don't have any problem with it. I have my 1, negative 2, negative 3, 1. I'll have my negative 4. But with the last one, let me divide through by what? Negative 3 and switch it to my second. So I'll have here to be what? Let me divide through by negative 3. So I have 1 again. This becomes what? negative 2 becomes negative. This becomes 2. And this becomes what? Negative 1 out of 3. So, or out of negative 3. So, become positive. At this point, I have my second third row to be negative 3, 7, negative 1, 1, negative 3. And the last row to be 2, negative 5, 4, negative 3, 7. Good. So we are still there. At this point, you can clearly see that I can use any of these to clear off my 3, clear off my 2 again. So let's do some quick clearing. Otherwise, you'll be writing plenty. So first of all, I can clear this by multiplying here by what? Not even multiplying anything, just subtracting will give me 0, right? So I'm subtracting everything here from here, right? Make it 0. So I have my 1, negative 2, negative 3, 1, negative 4, right? Subtracting, I'll have here to be 0. I'll have here to be 0. Subtracting, I'll have here to be 0. Then I'll have here to be what? Negative, no, positive 1. Then subtracting, I'll have 1 out of 3 minus 4. So plus 4. So 1 out of 3 plus 4 is 5 from 4, right? So 13 out of 3. Then I'll have, um, that's 13 out of 3. Then I have this here. So with this one, what do? You can clearly see that I can just multiply here by what? Negative 3 and subtract, right? So, or 3 and add. Let's do that way. So multiplying row 1 by 3, I'll get here to be 0. This is going to be negative 6. I'll get here to be 1. This is going to be what? Negative 9. When I add, I'll get here to be negative 9. I'll get here to be what? Negative 10. This is going to be what? Negative 3. I'll get here to be negative 2. This is going to be negative, oh no. I multiply through by positive. So 3, 0. This is going to give me negative 6, 1. 3, negative 9 plus 1, then negative 10. 3 plus 1 here to be 4, not negative 2. 4. 3 times this is negative 12 plus this negative 15. Then we are not done. The last row, I'll multiply the first row 2 by 2. I can still subtract, right? So by 2 and subtracting, I'll get 0. By 2, I'll get negative 4 when I subtract positive 4, negative. By 2, I'll get negative, right? When I subtract, I get positive by 2 when I subtract 5. And by 2, that's 50. So we are still there. At this point, you can clearly see that I can switch and bring this row down, right? I'll have 1, negative 2, negative 3, 1, negative 4. Then switching and bringing this row down, I have this one being the second row, right? So I can't. So here we can even do a lot of elimination. I can add this one to this and clear off this, right? So you let maintain that. So 0, 0, 0, 1, 13 out of 3. When I add these two rows together, what do I get? Let me add these two rows and put it at my third row. I get 0, 0, 0, and I get negative 1. When I add, I'll get 0 here as well. Right. Then the last row remains as what? 0, negative 1, then negative 5, 15. So at this point, I believe clearly that I can easily switch my last row to my second row. See, with the row operation, it doesn't have any order. You just have to be careful. 1, negative 2, negative 3, 1, then negative 4. Switching the last row, second row, I'll have 0, negative 1, 10, negative 5, 15. Then these two rows, remember I can add them. When I add this plus the last row, everything will be 0. I'll have mine. That will go to the last 0, 0, 0, 0. When I add, I have 13 over 3. Then finally, itself becomes the third row 0, 0, 0, 1. Right, this. Then 13 out of 3. So at this point, what are you seeing? You are seeing that you have all zeros, but this is it. So the question asks that, what's the question? It says that show that this system is inconsistent. To show that this system is inconsistent, we can see that the rank of the matrix is what? 1 and 2 and not 3. The matrix has three ranks: one, two, three. What's the rank of the augmented matrix? One, two, three, four. Therefore, they are not equal. Since the rank of the matrix and the rank of the augmented matrix is not equal, it is inconsistent. So that you have all zero, but you have a value here. It doesn't make sense. So it's inconsistent. I would like to end here. All the best in your exams, and you've got to solve more problems, but you've got to do personal practice. And see you. If you haven't subscribed, please do what? Subscribe. Please share to your friends. See you.